Alright guys, ran into a little situation I'm trying to figure out. So this project is the shaft for the Hendey. This is that power feed shaft that was running in bushings, and the bushings were shot and the shaft was scarred up, so I made a new one. So it fits in here, and it's driven either by the gear, or this is a V-belt pulley. And the actual gearbox that I took off is here. So that sits on there, and you can kind of see, I'm going to show you, that's a slotted hole for the belt adjustment. The bracket, the cast iron bracket I'm talking about, goes on the outside of that bushing and pinches it, and it swings for belt adjustment. Okay, let me kind of zoom you back around. Well, excuse the handle from the Van Norman milling machine. It's in the shadow, but you can see the that slotted hole for the, rotating, snugging up the rotational of that bracket for the belt adjustment, and it goes on that pulley. So basically, the locating surfaces of this bracket, excuse me, in this lathe power feed casting, is it registers on that round outside of that bushing, and it goes on that flat, I believe that's a scraped surface. So that's how it registers. So I wanted to show you that. Let's go over to the metrology bench, and it is a zigzag through this packed shop. It's a trade-off, right? The machine's packed in here. Alright, as I get close, this lamp will automatically sense my presence. Come on, alright, so so this is what I have. This is the casting I was talking about. Yep, let me pick it up. So the gear goes in there, and the shaft and the bushings go in there. So the casting has that pinch area for the bushing that I showed you, pinches around the bronze bushing, and this face, and you can see the scrape marks, and it's not really that, well, that's what I'm here to talk about. So that's a threaded hole, a 3/8 16 threaded hole for the bolt that goes in that slot, and it just goes up and down and rotates about the axis that is that bushing where it pinches. So I got the, alright, let me flip it. So that's where the gear goes. There's a gear that goes in the middle, and this side with an overhung load is the pulley that rides on the belt, and the belt goes on the spindle, and da 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 da. So the overhung pulley goes in that bushing, which is now going to be a needle bearing, and then it goes with a gear here. Okay, and this is just sort of a blind end of the shaft, just spins in there, and there was another bushing in there. My problem is stuff is not flat. Okay, so you can see the profile of this, right? So I've got this flat block, ground block. I'm going to set this like that on the surface, okay? Okay, so that's there, and I'm not going to do it, but I ran the indicator all over this surface, and I get an 8/1000ths deviation surfing, the probe tip all the way around. Okay. Okay. Well, I should surf that. That's not the register surface, the other side is, but anyhow, the reason I'm talking about all this, right, is who cares, Doozer? Well, what I'm looking to do is bore out, so this is 3/4, and I was able to source a Torrington, I think it was like a BN 108 or something, or you know, the double wide is the 1016. So I found a 1-inch wide needle for there, or you can get 2 1/2-inch wide needles, whatever. And the shaft on this side is 5/8, but the shaft on this side is 3/4. And I could leave it bushed from, so that's a 7/8 hole. They're both 7/8, right? Through and through, that's one, they're both 7/8. So I found a needle bearing for this, the pulley side, which is kind of where you need it, because the offset load of the belt, tension, the gear will be in the middle, and I could go back on this side with another bushing, and I ordered one for McMaster Cars, so it's coming. And I also ordered a needle bearing, but the needle bearing, the outside is not 7/8, it's in 1 inch, so I'd have to bore this out to 1 inch. So what I was doing is I can set this on the mill table of my jig bore. I was trying to set it up on the jig bore with a 1/2-inch stud going there with a nut and a washer accessible inside there. So I was putting it on the mill table basically like that, so I could indicate this and bore it out from 7/8 to 1 inch for the needle bearing. Like I said, the other side's fine, but this is not a 5/8 shaft, it's a 3/4 shaft, and it takes a bigger needle bearing. So I could either leave the bushing, the oilite bronze bushing, or bore this out to 1 inch. But I need to figure out, are the bores, you know, is this bottom surface perfectly 90 degrees to these bores? Because that bottom surface sure ain't parallel with the top surface by like 8 thousandths. And the scraping on this is pretty sparse. You can see, if you surf this top surface, if you set this on the plate and surf this top, this is pretty up and down. But if you set this on the step, right, and you surf, alright, if you set that there and surf this, like I started to say, and this has been turned. I believe this has been no, this does not look like a lathe turning. This looks like a big spot facing tool. So this was done at Hendey in Torrington, and this was probably done on some kind of mill. See, Pratt & Whitney had a 2A Pratt & Whitney. Hendey had a 2A Pratt & Whitney jig bore, but I doubt they'd use it for this. This was probably done with a big spot face cutter on a milling machine, because you can see the surface. I don't believe that's a lathe turned surface. It looks like it was done with a spot face cutter. So who knows what the hell is flat on this, and I don't really know how to tell, other than, like I said, that's 7/8. Grind up a solid steel bar mandrel that's a few tenths over 7/8. Grind up a mandrel, and you'd have to either press it on with a very, very, very light press fit, or whatever. A straight mandrel, not a tapered mandrel. And chuck it in a collet, 5C collet, and indicate the end of the bar for 0 and tap it in and measure the face and take maybe a skim cut or something. I don't know. I'm almost tempted to put the needle bearing in the pulley side and just leave the bronze bushing on the opposite side. And I'd have to make sure I oil the bronze bushing. But all the load is on the needle bearing side. So maybe I should just say this would be the needle bearing side. This would be the bronze bushing side. If I just pop a bushing in there and pop a needle in there, right? And you know, drill the oil hole for the grease fitting, this oil fitting, whatever, I could be done with this. I don't know what I want to do. If I should make a shaft and spin it, I can't think of a better way. I got a little square I could stick down there, but that's just a visual, you know, you can't really... I think the only reference surface that I need to... Okay, and I'm saying all this, and I didn't kind of start at the beginning. Well, maybe you understand. If I clamp this surface down to the table of the mill or the jig bore in order to bore out that side, this has to be 90 degrees perpendicular in this direction and in this direction, all the way around, 90 degrees to the bore, or else it'll sit, you know, crooked this way or crooked this way. And if you just indicate it one little thin ring around it, you got to indicate top, and bottom of the bore to make sure that it's not, you know, aimed funny. So that'd be a pain in the butt if if that surface isn't, you know, and I can't make assumptions. Because basically I need to reference both of those bores on a bar and then true up one of them surfaces. And I don't want to true up the bottom scrape surfaces. This is really the surface that needs to be true. This is the surface that needs to be true. So I could press fit a bar from the backside, put it in the lathe, and if I skim off 5 or 8 thousandths to true it up, that's going to be what I might have to do. Or just leave it a bronze bushing on the back, and this will be the needle. Sorry for all the conversation. Tell me what you guys think, what you would do. So that shaft, which is currently a bushing, is 3/4 of an inch, and it will be running about 2,000 RPM. And same for the needle bearing. It's about it's a 5/8 shaft, and it would be also coarse 2,000 RPM. I think maybe it'd be about 1,500 RPM. I don't know. All right. Leave a comment. Thanks. Do the shop.